Hello everyone here. This is Eason Lee from Simple Academy Singapore. Today we are going to talk about remainder problems. Actually, in the first round we have practiced some remainder problem merely about remainder calculating, right? So there is a formula, maybe about power or about a sequence. Then we calculate the remainder of the conclusion, right? But this is the most basic way to test remainder. The remainder is maybe the most difficult part in the number theory of primary school. So in special round, we have every year we have 1 or 2 questions that are about remainders, but they always tested us in a different way. They do not ask us directly about what's the remainder of a certain formula. Instead, they ask us to use the knowledge of remainder to solve some problems. Some may even have no remainders in the question, no such a word, but we should use the correct method to solve it. So there are so many questions. I have to choose only 2 of them, as in the video we can have only 2 questions in 10 minutes, right? Okay, now the first question is the 2022. It's last year. So this is this is a 4-point question actually. This is question 4, right? So this is a 4-point question. So it says that A is a 2-digit number and A plus 17 is a multiple of 5, which we can write as, and the difference of A and 17 is the multiple of 6. Note that we do not know is either 17 minus A or A minus 17, but we see that we need to find the largest possible value of A. So to make A the largest number, we should make A to be larger than 17, right? So there is A minus 17. So this is a multiple of 6. Then, here we have 2 divisible conditions. But how can we solve out the A? First of all, we can list all the possible way up, as we should find the largest possible value, right? So we just maybe starting from 99, 98, and 97 and have a try. This is a way. This actually is a way to solve it. But it's not so elegant, right? So to be smarter, someone may have noticed that there is A plus 17 is a multiple of 5. So the last digit can either be 0 or 5, which makes the last digit of A be either 3 or 8, right? So then we may list it up for fewer work, maybe starting from 98, then 93, then 80, 88, then 83, right? So then we can find out the answer. So this is actually a way. But I do not want to introduce you this way. I want to tell you something that sometimes when we find that a sum or a difference is a multiple of some number, this is always the case that we should turn it into a remainder problem. So remember, the divisibility of a sum or difference means it is a remainder problem. We should turn it into a remainder condition. So now here we have A plus 17 is multiple of 5, which means A plus 17 should have a remainder of 0 and divided by 5, right? Then, as the remainder can be add or be minus, we can have A should have a 3 mod 5. That is the same meaning as A has a last digit of 3 and 8, right? Also, A minus 7 has a remainder of 0 mod 6. Then A shares the same remainder as 17, so which is 5 when mod 6. Now here, we have turned the question into 2 remainder problem, right? So A has a remainder 3 when divided by 5, remainder 5 when divided by 6. So this is what we call a remainder problem. For the same dividend, right? We have different divisors and different remainders. We should solve the dividend. Now this is a remainder problem. Yeah, to solve this, there is many ways. First of all, we can list it up like we have already done before, or we can use the algebra way, which is more often used in secondary school. Yeah, I will give you an example. So for example, here, like we have A has a remainder of 3 when divided by 5. So which makes A to be 5 times K plus 3, right? So K should be a whole number or a positive whole number, right? Then, in this formula, we define A to have a remainder of 3 when divided by 5. Then we need to satisfy the mod 6 remainders. Now, it comes that 5K minus 3, which is A, has a remainder of 5 when divided by 6. Then 5K will have a remainder of 2 when divided by 6. Now, as we have a 2 here, a 5 here, 2 cannot divide it by 5, right? But we know that 6 has a remainder of 0 when divided by itself. So, to the right side, we can maybe add up some 6. And the remainder shall remain unchanged. So they also share the same remainder, right? So we can add up the divisors to the right till the right should be a multiple of the left 5. Of course, then 3 times 6 is an 18. So if we times 18 here, would make 5K to have a remainder of 20 when divided by 6. And then K should have a remainder of 4, when divided by 6. So now, we have the formula of A, then the remainder of K, right? Then K can be 4 or 10 or 16, each time added up for 6. And then use 5K plus 3, we get the value of A, right? So it can be 23, 53, 83, or 103, which is absolutely 113, which is absolutely not a 2-digit number. So we get all the possible value of A, and from them, the largest one is 83. So now this is a remainder problem. It looks like a multiple, it looks like a divisible problem, but actually, if we're talking about sum and difference, we should think it a remainder way. So similar things happened in the 2018 questions, right? This is a 4-point question. So we should choose two digit number from 1 to 100 and to make their sum a multiple of 5, right? We see the sum again and we see the multiple again. Then, if we want to make a sum, the multiple of something, we think it the remainder way. So we have A plus B is a multiple of 5. Then what is the remainder of A and B when divided by 5? So there is 1 to 100, right? So for a natural number when divided by 5, the remainder have 5 different conditions. We can have 1, 2, 3, 4, and 0 when divided by 5, right? So we can classify all the numbers into 5 groups. For example, 1, 6, 11, they all share a remainder of 1 when divided by 5. So this is remainder 1 group. Then the remainder 2 group is 2, 7, 12, and the remainder 0 group is 5, 10, 15, right? So now we classify all the numbers into 5 groups. Each group, we have 20 numbers. then it's the time we need to have a think. So if we want two numbers to have a sum of a multiple of 5, a remainder of 0 when divided by 5, so what's the condition of these two numbers? Actually, there are 3 different conditions. The first thing is that if we choose 2 remainder 0 group numbers, right, as they are both multiple of 5, their sum should be a multiple of 5, right? And secondly, if we choose 1 from the remainder 1 and 1 from remainder 4 group, and 1 plus 4 is a 5, which means a remainder of 0, right? So, this is another condition that we can choose 2 numbers to form the sum, a multiple of 5. The third is 2 plus 3, obviously, right? Now there are 3 different conditions. Then we need to calculate. So, how many different choices among these 3 conditions? So first of all, about 0 plus 0. So we should choose 2 numbers from the same group, remainder 0, right? The remainder 0 group will have 20 numbers. So this is choose 2 numbers from 20. So it will be 20 times 19 and divided by 2 times 1, which is 190. So the first case, we have 190 different cases. And the second and third case is more easy. As we are choosing 2 numbers from 2 different groups, we can just simply time them together, right? So, in the remainder 1 group, we have 20 numbers. 4 group also 20 numbers. So together we have 400 different choices. The same is for 2 plus 3, which is also a 400 choices. Then, in the end, we added them together, so total will be 990 choices. So the key point to solve this problem is to classify the number by the remainder and find 3 different conditions for us to form a multiple of 5. Then the counting part is easy, right? So that's the use of remainder. Sometimes in the question, they do not have the word remainder. They do not refer remainder, but they just insist you or suggest you to use the remainder way to make question much more easier. So there are many questions here, but here you should remember that when you see the sum and difference to be a multiple of a certain number, first of all, you should think about remainders. Okay, that's all for today. Thank you, and see you tomorrow.